Hello, everyone, and welcome. My name is Daniel Roth, and I'm a program manager on the ASP.NET team. I'm joined here today by Steve Sanderson, a principal software engineer on the ASP.NET team. Steve, do you want to say hello?
Hi, everybody. Thank you for joining us today.
In this session, we're going to talk about building modern web UI with Blazor WebAssembly. Now, suppose you want to build a modern, sophisticated web application. That app probably needs to run on desktop browsers. It needs to run on mobile browsers. Maybe you want it to be installable as a progressive web app. It's going to need a rich interactive UI, so you're going to need things like grids, dialogues, wizards, forms and validation. You also need to worry about things like authentication, localization, and so on. Now, a few years ago, the only way to build such an app would be to use one of these guys, to use a JavaScript framework and write your app in JavaScript or a language that compiles to JavaScript. Well, thanks to modern web standards, that's no longer the case. Blazor is a web UI framework for building single-page apps using .NET and C# instead of JavaScript. With Blazor, you can build your whole app with .NET. You get the productivity of C#, Visual Studio, a consistent and stable ecosystem to build your modern web UI, as well as a high-performance .NET backend. Blazor is open source, it's cross-platform, and it runs in any modern web browser on any platform. And today I am thrilled to announce that Blazor WebAssembly is now officially released and ready for production use. Blazor WebAssembly enables you to run .NET code directly in the browser using a WebAssembly-based .NET runtime that you can deploy with your app. When paired with .NET Core, Blazor WebAssembly enables full-stack web development with .NET. Blazor WebAssembly is now available with the latest version of the .NET Core SDK, and it also ships with Visual Studio 2019 16.6 and Visual Studio for Mac version 8.6. This release of Blazor WebAssembly is loaded with features. It supports .NET Standard 2.1, so you can just reuse your existing libraries on both the client and server. You can host your Blazor WebAssembly app in ASP.NET Core, so you get that full stack web development experience, or you can deploy your app as a standalone static site. Blazor WebAssembly supports authentication using ASP.NET Core Identity with Identity Server, or you can use Azure Active Directory, Azure Active Directory B2C, or any OpenID Connect provider that you want. You can build progressive web apps with Blazor WebAssembly and support offline execution and native OS integration. You can debug your Blazor WebAssembly apps, both in the browser DevTools and directly from Visual Studio. When you publish your Blazor WebAssembly app, any unused code is automatically trimmed to dramatically reduce the download size of the app. We also aggressively pre-compress the published app to reduce its size even further. You can configure your Blazor WebAssembly app as well as localize it so it's ready for a global audience. It's easy to get started with Blazor. Just go to blazor.net and then download and install the latest .NET Core SDK, version 3.1.300 or later. You can then build your app using Visual Studio for Mac, or Visual Studio Code with the C# extension. Let's go ahead and do that. Let's go build our first Blazor WebAssembly app. All right. First things first, we're going to need to pop over here to blazor.net. This is the Blazor homepage. Blazor.net is the magic URL that you're going to want to use. That'll bring you here. Just click on Get Started, and then go ahead and read through these steps to set up your machine and build your first Blazor application. I've already done these steps, so I'm going to go ahead and pop open Visual Studio. Let's go ahead and create a new project. And then let's search for the Blazor template. There it is. Click Next. That looks like a great name for a Blazor app. All right, and then here we see the two options for creating our Blazor application. The first option is a Blazor server app. Now, what is Blazor server? Well, Blazor server runs your UI components on the server using .NET Core, and then handles all of the UI interactions and updates over a real-time WebSocket connection with the browser. Blazor Server shipped last year with .NET Core 3.1 LTS. The second option is Blazor WebAssembly. In a Blazor WebAssembly app, your app is downloaded directly into the browser and runs on a WebAssembly-based .NET runtime. That's the option we're going to pick today. We're also going to select a few of these other options. We're going to select these two right here. What are these two? Let's go take a look. The first one is ASP.NET Core hosted. What does that mean? Well, a Blazor WebAssembly app, when it's built, is just a bunch of static files. You can deploy them as a standard static site, like to GitHub pages or Azure static sites. But when you decide to host that app instead in ASP.NET Core, well, now you've got that full stack web development experience. Now, the second option, progressive web app, what is that? Well, a progressive web app is just a web app, but it implements a few additional open web standards, so the app has a more native app-like feel. For example, the app can function offline, or it can be natively installed on the OS, so you can pin it to your home screen on a phone, or you can launch it from the Windows Start menu. All right, so those look good. We'll select those. We're also going to go and add some authentication to this app. Let's add individual user accounts, click OK, and let's go ahead and create our application. Visual Studio is now going to set up the solution for this application. And this is going to be a multi-project solution because we selected that ASP.NET Core hosted option. All right. Here it comes. Great. So now you can see, let's go ahead and get this building. You can see that we've got 3 projects in the Solution Explorer. We've got the server project. That's our ASP.NET Core app. That's the part that's going to host the client project, which is our Blazor WebAssembly app. And all the UI lives in this client project and all these .razor files. All right. And then we also have this shared project down below. That's just a normal .NET standard class library that's referenced by both the client project and the server project. All right, great. Let's go ahead and run it, and let's see what this app looks like. All right, so this app is just going to be a simple single-page app style application. Okay. Have a few tabs on the left-hand side. There it goes. All right, so we've got a home tab, a counter tab, fetch data tab. We can click around. All of this is client-side routing. Every time I click on one of these tabs, the browser navigates, but Blazor intercepts that navigation and routes the navigation to the correct component. There's no server requests happening here. On the home page, we just have some static HTML. On the counter page, we've got a button that we can click, and the count goes up. Notice there's no page refresh happening here. Normally, this would require JavaScript in order to implement, but I didn't have to write any JavaScript at all here. This was all done with .NET and C#. To show you that that's really the case, we can actually debug this app directly in the browser and see the code executing. I'm going to bring up the browser dev tools, and then we'll just pull those out into a separate tab, and let's snap them over here to the side next to our application. All right, we'll give ourselves a little bit more space just so we can see what's going on. All right, and we'll collapse this. Most of this app looks normal. We have HTML, we've got CSS, but down here below in this files node, notice we've got our C#.NET code. We can see program CS. This is the entry point for our application, like you would have in a console app. And then we can even see our UI, like counter.razor. This is the actual counter that we're seeing in the counter tab. We can set a breakpoint right here in the increment count method. This method's going to get called whenever this button gets clicked. Notice this button has an on-click event handler, which instead of pointing to JavaScript, it's pointing to our C# code. Let's go ahead and click the button, and there, we just hit a breakpoint in .NET C# code running in the browser on a WebAssembly-based .NET runtime. We can even inspect the local state for the component. Let's go look at the current count. It's currently 8. That's correct. If we F8 to continue, click the button again. Now it's showing 9. So we get a full in-browser debugging experience for our .NET code. Let's go ahead and let that finish up. Now, if you want to debug your app, you can do it from the browser DevTools like this, but you can also do it directly from Visual Studio. Let me show that next. Let's go ahead and close this. I'm going to go back to Visual Studio, and this time I'm going to hit F5 so that we launch Visual Studio with the debugger attached. Now, what Visual Studio is going to do here is it's going to launch the browser with remote debugging enabled, and then connect to that browser tab through a .NET debugging proxy that allows it to debug the .NET code executing in the browser. Okay, let's go ahead and find our counter component again. There it is here, this time in Visual Studio. All right. And then now let's go ahead and set a breakpoint on our increment count method one more time. And then we'll just go back to VS and wait for the app to load. Just takes a second. All right. So now we can click around. We can see our counter tab. And then if we click me, sometimes just takes 1 second. And oh, looks like machine's operating a little slow. There we go. Sorry about that. I guess I had a little hitch in my processor. But there, we hit our breakpoint in Visual Studio. And we can inspect the local state. We can see the current count. F5 to continue. Go back. Let's click it again. Hit the breakpoint. Now it's functioning fine. And we can see the current count has incremented down below. We can even hover to inspect the state. So that's debugging from within VS. All right, what else do we have going on in this app? Well, we have this Fetch Data tab. What does that do? Oh, well, it looks like it bounces me to the login page. Why is that? Well, if we look at the code for Fetch Data, it's mostly just an HTML table, and it's rendering out this weather forecast data as a table. And it's using a C# for each loop to render each row in the table, iterating over this weather forecast array. But up at the top, we can see that this component has an authorize attribute, which means that this weather forecast data is super secure, right? This is secure data. Only logged in authorized users can see it. So I guess I need to log in. So I'm going to register a new user. This is a new app, so I got to set up a new user account. Just quickly do that. All right, there we go. Type in the password. We're also going to have to initialize the database because this is a brand new application. So we'll go ahead and apply the database migration so that the table schema is all set up. And then we can go ahead and confirm our account and actually log in. So let's go ahead and log in using the account we just created. And we now should be able to see, we don't need to save that password, our ultra secure weather forecast table. So that's authentication with Blazor WebAssembly. We get all the features of ASP.NET Core Identity. Now, the last thing I wanted to show with this app is notice that Edge has detected that this app is actually a progressive web app, and it's installable. If I go ahead and install it, I now get that same app with a nice native shell. If I go to the Windows Start menu, I can see that the app now shows up there, so I can launch it from the Start menu. How is this possible? Well, when we checked the progressive web app option, it set up this project with a couple of additional files. It gave it a manifest file, as well as a service worker, which can handle caching all of the files that make up this application in the browser so that they're available to work offline. So in just about 5 minutes or so, we built a Blazor WebAssembly app that supports debugging in the browser or from Visual Studio, has full authentication support. It's a PWA, pretty simple. Now, this is a very simple app. Like, this is just the default template. If you've been following along with Blazor, you've probably seen this app a few times before. Let's go take a look now at a more realistic application. I think we can go ahead and close this instance of Visual Studio. I have another Visual Studio instance open with a different app that is called Car Checker. And Car Checker is an app that would be used by an attendant at a car rental company for checking in cars that are being returned by customers. And you can see, it's got quite a bit more going on. It's got quite a bit more UI. Now, I've already built and run this app, and it's a PWA, a progressive web app, and I've installed it locally on my machine. So I should be able to go in here, and there's Car Checker showing up in my Start menu. Let's go ahead and launch that. So this is a Blazor WebAssembly app now running in that nice native shell as a PWA. You can see that I've logged in. It supports authentication. The car attendant now would search for a license plate number. Like, let's look for this car right here. Notice that it's auto-completing. Again, this would typically require JavaScript to implement, but this was all done with .NET and C#. We get a nice 3D visualization of the car. Looks like this car has been a bit beat up over the years. It's not in great shape. It's got smashed in windshield and all sorts of terrible things. This 3D rendering was actually done using Three.js, a very popular 3D rendering library. And this shows that if you want to still reuse some of your existing JavaScript libraries, you can do that from Blazor using JavaScript interop. The intendant can now put in the mileage, let's say 43,000 miles. If they put in something ridiculous, you get forms and validation. Let's put it back to something more reasonable. Let's say this car was returned with 75% of the gas. We can then add notes to the car to say, there's an issue with this tire. Let's add a note. Again, if I just try to save, we get forms and validation. It's all built in. Let's see, what's the problem with this front left wheel? Well, it was returned completely missing. How is that even possible? How did the user even drive the car? I don't know, but they did. All right, and then let's go. We can upload a picture. So we've got file upload. There's a picture of our car with its missing tire, and we can save that. And now we've got our new note, and it's added to all the other notes. We can then save this, and it's persisted to the server, all in a secure, authenticated way. So pretty rich application, nice UI. It's got a nice responsive user interface. It works on large form factors. It works on mobile, all with the responsive style user interface. Okay, but let's say that the attendant though is out in the parking lot and they have spotty network access, like they don't have access to the server. Well, what then? Well, this is a progressive web app and it is set up to function offline. We can simulate that by bringing up the browser dev tools. This is just the normal browser dev tools for this app. Remember, it's all really a web app under the covers. And let's go to the network tab and let's just turn off network access. We're going to set this to offline. Okay, and then let's force a refresh. This is like loading the app for the first time. And you can see all sorts of network requests are failing because the network's not there, but the app still loads and it actually still functions just fine. We can go back to that car. We can see, the data that we added previously is still there. All of the files needed to run this app were cached locally, as well as all of the data needed to manage cars being checked in. Like, let's say the attendant changes the mileage again for this car and then tries to save. Well, initially it says it can't sync the data to the server because there's no network connectivity. But when they head back to the office where there's network is available again, then they can retry, and now the data gets synced back server side. So this app has full offline capabilities. What else? Well, let's say you have some customers or attendants that aren't English speakers. They need to speak a different language. Well, let's go ahead into Edge and let's fiddle with our language settings in the browser. Let's go in here and let's set our language. Instead of being English, let's set it to Spanish as our preferred language. Okay? So again, I'm going to force a refresh on the browser. And you can see now it's fully localized in Spanish. And this is using the same abstractions that you would use in any .NET application or ASP.NET Core application. If we go look at the code, we can see this app has a resx file with all of the localized assets for this application. So this car checker app is it's a PWA. It supports full offline access. It's using JavaScript interop in order to do fancy 3D renderings. It's localized. This seems like a production-ready app. Blazor WebAssembly. All right. Now, I'm sure you're wondering, how is that app implemented? Well, we don't have time to go through that in detail here, but Steve was kind enough to record an entire on-demand session about that app in great detail, showing all of the Blazor WebAssembly features that it uses. Be sure to check it out at aka.ms/BlazorInAction. If you're going to be building production Blazor WebAssembly apps, you're also going to need beautiful and feature-rich UI components. Fortunately, our partners have been hard at work building Blazor UI component libraries. Be sure to check out their various offerings. I've also got to give a shout out to the Blazor open source community. These folks just like you, have been building component libraries, interop libraries, test frameworks, and so much more, and made it completely free for the entire community to use. Be sure to check out these various projects. You can find many of them on the awesome Blazor GitHub repo at aka.ms/awesomeblazor. Well, now that Blazor WebAssembly is shipped, what's next for Blazor? Well, we have a whole bunch of improvements planned in the .NET 5, .NET 6 wave. First, we're going to integrate Blazor WebAssembly into .NET 5. It will show up in an upcoming preview. Probably sometime in June is when we expect that to land. We also plan to do a bunch of improvements to the component model, like support type constraints, required parameters, async disposable. We're working on supporting hot reload, so you get that fast iterative dev workflow. We're looking at supporting CSS isolation, so you can have styles isolated to particular components. And then we have a bunch of WebAssembly enhancements planned as well, supporting support for threads, lazy loading, and performance improvements. This isn't everything that we plan to do in the .NET 5, .NET 6 wave, but it's the stuff that we're looking at right now. So I hope you're as excited about the Blazor WebAssembly release as we are. We invite you to go and give it a try by going to blazor.net. And now we want to turn the rest of the time over to you so that we can answer your Blazor-related questions. Steve and I will be happy to do our best to answer them.
All right, fantastic. That was great, Dan. Well, while you've been doing your talk there, I've been watching the stream of questions that have been coming in, and there have been loads of great questions. We definitely won't get through them all. Hopefully many of them will just be answered online, but I'll bring up a few of them now. I thought I'd start you off, Dan, with some really easy ones just to warm you up.
Oh,
so the easiest question of all is from Louis Gustavo, who asks, is Blazor ready for enterprise applications and production scenarios?
Well, yes. I mean, we're using it in production. Actually, we deployed Blazor WebAssembly into production on the .NET team like quite a while ago. The try.net site, which is all based on like an in-browser experience for writing some C# code and being able to run it without having to install .NET. That's actually all running on Blazor WebAssembly and has for like many preview releases, which was great. It enabled us to really reduce the cost of that infrastructure. But we've been talking to many customers that have been building with Blazor since it's been in preview, and many of them are actually already using it with production workloads. Blazor Server has shipped, almost for like 6 months now, when it shipped with .NET Core 3.1 LTS. So Blazor Server actually has an LTS support cycle. Blazor WebAssembly now also fully supported and ready for production use.
All right, fantastic. Next question, super easy, so I'll just answer it immediately. Jose asks, is this possible to run this application on Mac OS? The answer is yes. It's web-based. It just works on any operating system. If you want to do your dev on VS Code on Mac, it will work fine. Also on compatibility, Josh has asked, what's the oldest version of Internet Explorer on which it works? Dan?
There is no version of Internet Explorer in which Blazor WebAssembly will work, and that's because Internet Explorer doesn't support WebAssembly. It has no WebAssembly support, and it won't. So you need a modern browser that supports WebAssembly to use Blazor WebAssembly. If you still want to use Blazor, you can use Blazor Server with IE 11 with sufficient polyfills, and that is possible to get working because Blazor Server has a much thinner client. So yeah, IE 11 is pretty much the oldest version that you'd be able to use this technology with.
Very good. All right, let's move on to slightly more medium difficulty questions now. Benito P has asked, can we use native dependencies such as CDLLs or something that's been built from C++ with Blazor WebAssembly? Do you want to answer that, or do you want me to?
Why don't you go ahead, Steve? I think that's right up your alley.
Yeah, because I'm the developer. Okay, so the answer is yes, but it's hard. So you could take some code that is written with C or C++, and then you can compile that to WebAssembly using a toolchain like mscripton. That is actually how we compile the .NET runtime to WebAssembly in the first place. So that clearly proves that it's possible. So if you take some other code and compile it to WebAssembly like that, then yes, you can call to it from your .NET code, which is running on WebAssembly. Today, it's a little tricky because you have to go through the JavaScript interrupt system to do that. It's quite an advanced thing to do. Longer term, we're looking at ways that we could make it more straightforward, just more like a p-invoke kind of thing. But for today, yes, you would be going through the whole JavaScript interrupt layer to do that. It's not a very mainstream thing to do, but I thought it was interesting. Okay.
I think it's worth pointing out there, Steve, that like Blazor WebAssembly apps, they just run in the normal browser security sandbox. Like they're not getting like somehow native access to the machine. There's no like backdoor that they're sliding through. We're just running using normal open web standards. So the way you should think about what is possible is, well, if you can do it in JavaScript, you can do it in Blazor WebAssembly using the same patterns at the very least, or hopefully with .NET abstractions on top. If you can't do it in JavaScript, like running a random C library, then you're not going to be able to do it from Blazor WebAssembly either.
Yep, that's great. Okay, now we've had two questions on a very similar subject, so I think maybe this is of interest to people about whether your code can be read by people using your application. So Francesco has asked, is your code exposed in DevTools in production in any way? And Philippe has asked, concerning client publication, does all C# code go with it, or is there any kind of minification or obfuscation?
So the DLLs that you build for a Blazor WebAssembly app get downloaded into the browser, and the user can grab them and try to decompile them and look at them. You can try to prevent that using standard .NET obfuscation technologies. But yes, the DLLs will get downloaded to the browser, and the user will be able to see them. The debugging infrastructure that you saw, like that is intended to be used only in a development environment. That's not something you should expect, like the actual raw C# code is not something you should expect to see in a production deployment. Now, if you build a Blazor server app, the app code stays on the server. So if you run your app that way, then none of your .NET code leaves the server and the user can't see any of it. All a Blazor server app is doing is managing all the UI interactions over like a WebSocket connection. So the user doesn't see that code in that mode.
Yep, that's right. Okay, and I'd like to just clarify that this is absolutely standard for web development. This is not specific to Blazor, but if you build a single page application with any sort of front end technology, then it's absolutely normal to be deploying your UI code into the browser. And there's very little reason in most cases to be concerned about trying to obfuscate it in any way. It's very unlikely that you've got some kind of special secret source in there that that would be problematic to expose. In the case that you actually do, then yes, just keep that code on the server. You can call it from the browser if you want to. A good example of that would be some kind of ML model that you've spent months training and perfecting, and you don't want to include that. So yeah, just keep that on the server and call it from the browser if you want to keep that a secret.
Like doing a web API call, like just a normal HTTP call.
Yeah, absolutely. Okay, so we've got 3 minutes left. Let's just do a hard question, or a question that's like not as favorable to us. So Torgia, I hope I've pronounced that correctly, is asking about the application size. Now, at the moment, I don't think we emphasized it too much in the talk, but by default, the Blazor WebAssembly app will be about 1.8 megabytes or something after it's been published, and can 1.85 or something like that, and it can come down to about 1.7 or even 1.6 if you do a bunch of things to really squeeze it as small as you can. But the question has been, is it realistic to reduce it to 100 kilobytes or so? I guess this person has got a certain size target. And I would say, no, that's not going to be realistically possible. What we're doing with Blazor WebAssembly is we are including a .NET runtime inside your page. That's not going to be tiny. There's a lot of functionality that's been included there. So while we work as hard as we can to make it as small as we can, I don't think there's any realistic world in which it's going to be 100 kilobytes. But on the positive side, if you look at just about any realistic published real-world application, you will probably find that it's going to be in the megabytes already, and Blazor is not going to be disproportionately large compared with that. And another mitigating factor is that this is all cached. It's only a one-time thing for any given user. When you restart the application in the same browser later, it can be less than a single kilobyte that gets transferred to start the application up again another time. So yes, we can't eliminate the fact that there's a lot of sophisticated stuff in there, but we do what we can to make it as non-problematic as possible. Anything you want to add, Dan?
I think that's it. Thank you, everyone, for attending. And again, I hope you will go to blazor.net and give Blazor a try today. Thanks for your questions, and thanks for watching.
Goodbye.